Okay, so welcome all to this new session, our webinar on urban mobility observatories, whose title is Demystifying Technical Aspects of Urban Mobility Observatories. And this is a webinar jointly developed by the consortium of Suez, Transitec, de Ville des Hommes et Oslandia, in partnership with the Center for Excellence in Urban Transport, who develop urban mobility observatories in 3 Indian cities, Ahmedabad, Kochi, and Nagpur, in a project that is financed by AFD, the French Development Agency. This is the second webinar of a series of webinar that intend to share the experience of setting up such observatories based on the experience of the Indian cities and to be shared with the global Mobilize Your City community. So the first session was last Tuesday. In case you missed it, we will have a bit debrief of what happened during this session. And basically we discussed how to build a robust urban mobility observatory from scratch. And today we're going to see the more technical aspects of these observatories, the infrastructure needed, the options for replicability, and how to obtain data. So before starting this session, I would like to provide some general notes. So make sure you're muted and your camera is turned off because the session will be recorded, and once it's finished, the video will be uploaded on the Mobilize Your City YouTube channel. So if you don't want to appear on the recording during the session, you should keep your camera off and your microphone also off to avoid any interference with the speakers when they're speaking. Include your questions in the chat if you have any during the whole session, and I will try to organize them to ask them to the experts that are with us today. And we will also have 3 different moments during the session in which you will be able to speak up. And in this moment, you will be able to turn your microphone on and your camera on if you want to. And then again, don't hesitate to share your ideas, comments, and questions in the chat anytime you want to share something. So the learning objectives of this webinar are 3. First, it's understand how to use the Urban Mobility Observatory. As I mentioned the previous session, this is an very specific element that Mobilize Your City proposes when cities are developing a sustainable urban mobility plan. Appreciate the replicability of the methodology in any other city. And this is one of the added values that Mobilize Your City have, and it's try to share this kind of experiences, in this case from the Indian cities, with the global community to see opportunities of replicability. And the third objective is learn how to access geospatial data related to the data that was shown in the previous session. So the content will be, the first step will be this welcome and housekeeping, and then we will have a colleague of us giving us a reminder of session 1 and previous Tuesday. And then we will have the experts talking about the technical architecture of the platform, an open source structure, an opportunity to implement the tool for another city. And then the last topic will be geospatial data. Geospatial data, sorry, there is a type on the slide. And for each of these sections, 2, 3, and 4, we will have a few minutes to ask questions and then provide some answers. At the end, we will have a feedback and a farewell. So with us today, we have 3 speakers, Sylvain Beorcia and Vincent Bray from Oslandia, an organization that was part of building these urban mobility observatories in the Indian cities. We also have Julien Aller from Transitec, also part of the consortium that I was talking about before that helped to prepare this webinar. And then I will be moderating this session. I'm Nicolas Cruz, Sustainable Mobility Expert at the Mobilize Your City Secretariat. So Without further ado, I give the floor to Julien, who will provide a reminder of session one. I will tell us in a few minutes what we discussed and what we learned on Tuesday. So Julien, if you want to take the floor, it's all yours.
Thank you, Nicolas, and hello, everybody. Um, so, really, in a nutshell, I will present what has been discussed during the last webinar on Tuesday, which was really a session to present the urban mobility observatories that has been developed for the three cities of Ahmedabad, Kochi, and Nagpur, three Indian cities. And the project has been financed by the French Agency for Development under the umbrella of Mobilize Your City program in India. And in parallel, AFD and Mobilize Your City supported the elaboration of a sustainable urban mobility plan. In other words, in India, a comprehensive mobility plan in order to allow the the metropolitan corporation of Ahmedabad in developing urban mobility policy. So the urban mobility observatories has been presented by my colleague Laura Cornelis in order to first show the objectives of such observatories. In fact, we know how this kind of tool is really helpful for decision makers in many cities around the world, but it's not easy to set up because, first of all, in many cities, there is not a lot of data available, and second, it's not so easy to collect the data and to analyze it to make it useful for decision making. And what has been proposed with those Indian urban mobility observatories is a set of 20 indicators to understand the past trends and also to really have a comprehensive view on what is happening regarding urban mobility in the urban area. And those indicators can be easily updated, and a report is associated with this Urban Mobility Observatory website that you will discover soon with our Auslandia colleagues. And a report so is joined to this website to describe the way the indicators are structured, and finally how the data should be collected to populate the indicators. So that's the first section of the urban mobility observatories. The second is much more to present with the data visualization, with graphs, with maps, really to develop some as much as possible easy to understand tools to look at the future trends in terms of mobility and check the objectives of the public policy in terms of urban mobility. The third part of the observatory is much more to follow up the implementation of the SUMP action plan. finally, to really follow all the list of actions that have been approved by the 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 entity that is leading urban mobility in the urban area, and to really present to the citizens how much the public policy is advanced following the plan. And the last part that we have proposed in this Urban Mobility Observatory is in fact a way to collect easily more qualitative data on the demand regarding urban mobility, and finally to have feedbacks from the users and the inhabitants of the city on how do they move, how do they commute, etc., and how do they consider the different modes they use, etc. And this fourth part is really developed to try to in order to suggest, in fact, to decision makers from Mobilize Your City network to try to get feedbacks from the people in order to receive sometimes some confirmations that the mobility strategy is the right one, or maybe sometimes to get information about some challenges that are not really in the top of the list for decision makers. And it means that if this first section on digital participation is used by the cities who will have such urban mobility observatory, it could be a great way to involve as much as possible the public in the urban mobility policies. So that is what has been presented on Tuesday. And now with Vincent and Sylvain, you will see how this tool, how this website has been developed, and how much you can handle it easily, as it has been developed on open source softwares, and so it could be handled by different cities in the network, and also of course it could be updated and enhanced thanks to the contributions of the different cities who will use it. So maybe Vincent and Sylvain, I let you now the floor.
Okay. Thank you,
for
Julien.
a short presentation, and then we will have a time for discussions with our attendees.
Okay, thank you, Julien. Hi, everybody. Thank you, Julien, Nicolas, and Laura and Louis for the first part of this webinar last Tuesday. I am Sylvain, and with Vincent, we are very pleased to show you today a more technical aspect of the project. We've been working on it for a long time now, and it's always great when a project like this come in the lights and will become open source at some point. We believe this is a great project, and we hope many people will join the process so it can evolve in the future. I will start talking for part 1 and of part 2, and then Vincent will take the rest of the speech. First of all, we would like to quickly introduce our company. It's called Oslandia, and we are specialized in GIS architectures. That means we build cartographic web apps. We use and develop for QGIS software, PostgreSQL. We do some 3D projects, some data projects, all related to spatial data, geographic data. We only work with open source software. It's a philosophy for us. We'll talk about that later. Also, we all work from our home in France. We have no physical office. On the observatory's website, Vincent and I have been the dev team, and we mostly worked in collaboration with Laura, Etienne, and Julien. This morning, we will split the presentation in 3 parts. The first one will be dedicated to the architecture of the platform, understand what is the technical aspect behind the website. The second part will focus on the deployment of a new instance. For example, you like that project and you want to have your own observatories. How can you do this? And finally, we will focus more on the open source aspects, the open data, and how we can find and process that kind of data. In the end of that part, we will discuss also about OpenStreetMap. OpenStreetMap is the world's first open source map database. So we will see all that in that presentation. Okay, let's start. Last Tuesday, Laura showed us the observatories. As a reminder, it looked like this. Maybe you've already went on the website and tried it on your own. You may let us know at the end of this webinar. It's quite simple. We choose a single app design, which means that all is almost on the same page. You see on the top, we have the logo, the menu, the city selector. On the left, the widgets. We can call them the filters. And on the rest of the page, we have the map and the charts. And that's it. It's quite simple, but efficient, and we hope quite clear. Each part of the web site is divided in components. We have the navigation, the map, the charts, the survey, and on each component, sub-component. For example, on the map, we have the layers, the legend, the tooltips, and we try to provide the most efficient and ergonomic way to display the information. That was a great deal with this project. What you see on the website is just a part of the project. Behind, there's a lot, and that's we are going to see now. What you see on the web is just the tip of the iceberg. So how is it built? What did we use to process the data and display them like that? Let's talk now about the architecture. We will try to keep it simple so it can easily be understandable for most of us. So if you have questions, please wait for the end of each part or ask them in the chat, so we will answer them. So the architecture. We would like to begin with a schema, an overall schema which shows us a classic open source GIS architecture. It will be easier next to understand the one we choose for the observatories. So you see a big schema then. It may seem a bit complex at a first glance, but it's not. You can see two main informations on that schema. The first one is the way components are connected each other and where the data goes. And the second one is the way people are involved in the process. You can see the little characters. If we start with the component, on the left, we have the data. We spoke about data last Tuesday. Data is very important in a project like this. Without data, there is no website or maybe an empty website, which is quite boring. The data goes into the database via custom scripts or tools. The database is PostgreSQL with its spatial extension PostGIS. The data is then processed by the map server and the web server to produce layers, maps, JSON data. In fact, all the web clients needs. The web client at the right of the schema is the web interface you can see on the web, the tip of the iceberg. On the lower part, you can see QGIS, which is not really part of the web app architecture, but it is used for processing the data, viewing the data, test the data before import it in the database. It's really a daily working tool. And sometimes if the map server you choose is QGIS server, like you see on this schema, then QGIS become a full part of the architecture by being the place where the maps come to life by gathering the layers, add the symbology, edit the attributes, etc. Of course, I go quick. We will go more into detail after that. Now, if you look at the people involved, we have 4 profiles. The administrator in red, who manage the servers, configures the settings. We have the analyst in green, who process the data, use QGIS. We also have the operators in yellow, who collect the data, but also use the website and QGIS. Each one has a specific role. And remember, this schema is really generic one. For the observatories, the architecture is a bit different. We don't need a map server. By the way, we will define that what is a map server later in the presentation. So, what are the differences? Well, we don't need a map server for this project. Then you can see that the server part has been replaced by a backend. We call it a backend containing Python with Flash scripts. This is the server-side core of the application. We call it an API. It can read the data in the database and provide to the front end. The front end on the right is the web browser. Anything it needs means the layers of the map, the data for the charts, etc. There is one more user involved, the internet user, you can see in blue, whose role is only to consult the website. The other people involved are globally the same. Let's focus on each part, the data. There are many types of data. Classic types are text, data, numbers, dates, classic database data. But when you start dealing with maps, other types come into the game, like points, lines, polygons, which are vector data. And we also have raster data. Raster data is bitmapped images, like aerial images, some kind of this. Also, we can deal with 2D data, 3D data, point clouds, LiDAR data. In fact, a lot of sources available according that the job you want to do. For the observatories, the main types were CSV files. CSV file is globally Excel files, which were prepared by Laura and Etienne from DVDH, and shapefiles. The shapefiles are standard files for storing layers of spatial data. The data goes into the databases. The database we used were PostgreSQL with PostGIS. It's a well-known open source database with a huge community around the world. Its role is mainly to store the data for the project, but in many cases, Postgres can be used to process the data in simple or complex ways. We speak of thick or fat databases when its duty is not only to store the data, but also to bring some intelligence and specific processes to the project. The backend or the API has been developed in Python. It's a it's a development language, sorry, with the framework Flask. It's a custom API, means that we wrote it from scratch because the needs were very specific for that project. Its role is to serve the data. It processes, in fact, the communication between the database and the front end. In our case, the format used is mainly JSON and GeoJSON. It's basically a text format, very light and very used in a web application in our days. And finally, the front end. The front end, again, it's what you see when you are a web user. It is built with JavaScript, the framework React.js, very used in the world. And also we use OpenLayers and Chart.js. OpenLayers manage the maps. Chart.js manage the charts, and React.js all the rest. That means all the logic we had to implement for the observatories to work. It's a lot of work to have a dynamic interface like the one you've seen, but we try to stay as generic as possible to ensure easy evolution in the future. And this is a really important thing for that project. A component which is not showed on the schema, but which is quite important, is the infrastructure tool we need to have a good development workflow. In our case, we use Git and GitLab. The source code of the web app is stored on a Git server. It's basically code versioning. And GitLab is there to bring useful tools like the CI, which means continuous integration. It gives us the assurance that all the development are tested, validated before going onto the server. This is critical when you start deploying your own application on the server, especially on a public web server. I mean, nobody wants to see a non-working website. So we prevent that by setting up a development and a deployment workflow very secure as possible. Laura told us Tuesday that all the data were not yet on the server for Ahmedabad and Nagpur, but today it's up to date. And thanks to Vincent and that automatic process, we set it up to ensure secure deployments. Also, GitLab brings up a ticketing tool, so we could follow the evolution of functionalities in time. We work as a team with Etienne and Laura, and the platform was a way to follow the evolution. At last, Last component you saw on the schema, QGIS. Again, not really a part of the process in the end, but very, very useful during the making of the platform and during the preparation of the data to explore, designing, all that kind of thing. Okay, so you see, we don't use a map server for that project. So a few words about that. Why didn't use one? Why is it, first of all? What is a map server? It is basically an application on the server side which can read many sources of spatial data, then process them with rules for the symbology, and return some images which represent some maps. The map you can see on the web app. A map server usually follows some standards like WMS, WFS. I don't know, maybe you've heard of that kind of standards in the spatial world. And as you can see, we talk often about tiles and vector tiles. It is really important part in a map application in some case. But why not in the observatories? Why not using a map server? Because we have maps. But the map you see on the website are simple. It's just circle, polygons with a few colors, not very complex. Plus, we don't have much data to display. So that way, the browser can do the job. That means it receives the data from the API and is able to display it as a map with a good symbology. OpenLayers is a component which does that. The server, or the API, if you prefer, only send the data and the browser is working. That's common in modern websites when you want to see a dynamic modern website. And that's why sometimes your laptop start to eat or you can listen to the fan accelerating. That's because it's working hard to provide a dynamic website. It's not the server which is working, but it's your machine, your own machine, consulting the website. If there is too much data to display, then it can be a problem. Also, if the symbology is too complex, then the map server could be necessary. Tomorrow, it will be very easy to add in the process a map server if we have to display more complex maps. The front end will not change a lot, and it will be a matter of a new component in the process. If you remember Laura's presentation Tuesday, she showed us some aerial data which could arrive in the platform tomorrow. That kind of data would require a map server to be displayed. Not necessarily a big one, but at least one. If you look at a small, just quick comparison with two kind of maps, on the left we have the map you can see on the observatories. It's a vector representation of the data. It is managed by the browser, and on the right side you can see a bitmap image generated by a map server. And we can see that the symbology is more complex with labels, with spaces, with different colors on the right side. It would be difficult to do this without a map server. So don't be fooled. On the left image, the data is only the black lines. Huh? What you see in the background is OpenStreetMap, and Vincent will talk about that later. So, to conclude this first part, I would like to talk about the genericity of the application. We tried to be as generic as we could. It means that every component we developed come with settings. By changing the settings, you can change the way the data is represented. To give you an example, a chart you can see on the website is some data in the database, and some settings are in the front end, telling that we want a pie chart with specific colors. If you want to change it for a bar chart, for example, then it's just a matter of changing the settings. An administrator could do that job. The developer team, may be not involved anymore at that time. We have prepared all the need for the settings. All is not perfect, of course, but that was the philosophy. We often choose to process that way because of the reason you can see on the screen. Generic code, because it can be reused for a second platform. It can be reused for another data visualization project. It's easier to maintain in time. The transition to open source model is really facilitated. An admin can do the job, no more dev involved. And some example, if you want to add a new indicators, you don't need a new development, just settings, a new theme, a new theme, the same, a new map, the same, new widgets, etc., etc. So that was a quick, briefly explanation of the technical aspects of the platform. Next, we are going to show you how to deploy a new instance of the platform. We try to stay simple in that presentation, not to go too far in the details, because it can easily become really hard to understand. So to please everyone, that was really quick and simple presentation. So before we switch on the part 2 of the presentation, maybe you have some questions about what you've seen, and we will be pleased to answer those questions if you have.
Thank you, Sylvain. And I indeed invite participants, if you have any questions, to include them in the chat or to open your microphone and your camera and speak up directly to our speakers. You can also raise your hand if you want to take the floor. Otherwise, I would like to ask a question myself. Sorry.
Okay.
About the last part that you were talking about, because you said that you use this generic code, if I understood well, so it's easier to maintain and to replicate, and then a person that is not a developer can manage adding more indicators or changing data. So I imagine like this kind of person that can take care of updating the tool could be a person that is not trained in this coding world, and it could be like, for example, the person in charge of monitoring and evaluation of a sustainable urban mobility plan, for example, a person with a profile more into urban planning than into coding and developing. Is that correct?
That is correct. This is really the goal of at the end of the project. As I said, it's not yet perfect, so you have to have a minimum of skills to be trained to the tools to be able to set up the settings and do a deployment by your own. But that's the goal, that's the purpose, to propose a really versatile platform which you can learn, configure by yourself, and do the evolution, or add yourself some new charts, some new maps, and insert data for your own country or city by your own without any help of the developer. We are not yet here, but the code will be open source. We will try with, we hope, other contributions to set up the last aspect of the project, to make it even more generic, so everyone can take it and in fact run it on a server.
Perfect. Thank you very much. And this is indeed one of the things that we want to do at Mobilize Your City, and it's to make available tools that other cities can easily use. And I think that's why it's important also to keep doing this on the open source side of the things, because I know, like, for licenses and then accessing data, sometimes it's difficult because not all the information is shareable and available online. So let's see, I would invite you now to continue with the presentation. We will still collect more questions if there are any, but now we're a bit behind schedule. So if you could continue, that would be perfect.
Okay, thank you. So deploy a new instance. Again, a word about open source and open data as a general rule. As a reminder, we at Oslandia work only with open source software. It's a philosophy, I said that, and we also like to work with open data whenever it's possible. Why is that? We believe that software are meant to be shared so they can progress better and faster and be more efficient in the end. We prefer the customer to pay some people for a service instead of paying for costly licenses. So who can work like this? In fact, there are many companies in the world that have their business model based on open sources software. It works very, very well. Regarding the observatory, of course, you need a bit of skills on the technology involved. Last reminder, making a software is not only lines of code. People often think that making a software website is coding, but it's not only that. It's a lot of discussions, a lot of reflection, a lot of documentation, and good specification. And the human communication is really, really important. And we believe strongly in that at Oslandia. Okay. Now, I want my own platform, my own observatories. How do I do this? First thing, do I have data? Remember, no data, no website. Few data, you will have an unattractive website with it's not very good. If you have sufficient data, okay, we can go to the next step. So we've got the data. The source code is available, or it will be available when it will be released as open source. Do I have the skills? A member of my team have the skills? Yes. Let's go. Take the install documentation file and try it. I don't have the skill. I have to find someone who can do it. It's not yet plug and play, but it remains a custom platform for the moment. Most of the work you'll have to do is setting up some files and import data, but it still requires some skills. So you have the skill, go for it. Otherwise, you have to find someone who got the skill to manage the thing. So what's the process? First, you have to write some specification. As I said before, it is really, really important. You have to provide or ask for a graphic chart. You have to engage the process with the dev team, if you have one. You have to rent a web server. This is an important part. Keep in mind that you have to keep it in time. So watch the budget about this. A website is not a one-day investment. This is very important. You don't pay the web host for one day, for 1 year. If you want to have your website for 10 years, be aware that you will have to rent the server for 10 years. It's an important point to have in mind when you start a process like this. I saw many times some customers renting the server for 1 year, and after that, there was no more budget, and the server was shut down. It was a waste of, it's what a waste. How much does it cost? It depends. It depends on what you want. What do you exactly want? Do you want a perfect replica or a replica with your own colors, logo, data, charts, maps? In the open source software, the first to order will always have to pay more, to pay a lot, maybe. The process is initiated, but it will eventually get the benefits when other people will invest money to make the platform evolve with new feature, with shared experiences. Now we can see an overall schema of the deployment process of the solution, and maybe I will give I will let Vincent present us this schema. Thank you, Vincent.
Thanks, Sylvain. Hello, everybody. I am Vincent Bray. I am one of the developers of the platform. I will be taking the rest of the presentation. On the screen, you can see a diagram that summarizes the deployment process. In order to deploy a new instance, the first question you need to ask yourself is whether you have the skills or not, particularly in GIS-oriented IT development and in the technologies used by the project. If not, you will need to call an equipe of developers. Next, you need to ask about customization. If you need to, we will need to start a new deployment phase. Once this stage is complete, we will start installing and configuring your test server and deploying the application code on it. If you don't have your own server, you have to rent a server. Next, you will need to configure the application, the configuration files to suit your context, and at the same time, we will need to collect your data and import the data in the database. Then you enter in a phase of validation. If everything is done perfect, we will enter in a debugging phase where we will adapt the source code again, then deploy it on the test server for a new check. If this control passes, you are ready to deploy in production and share it with the various users. If you want a new feature, the first step is to create an issue in the project GitLab directory. An issue is a ticket where we specify all the specification. The more detail you provide, the better it will be for the developers. You can provide a detailed descriptions, with diagrams, models, so that the developer can get a better idea of your requirements and provide you with the costing the most accurate time estimate possible. Once the specification and costing have been validated, the development team starts work based on the elements provided and any meetings held before. Once the functionality has been developed, the customer validates it and makes any necessary adjustment before deploying on the platform. How can the platform evolve in the future? We can expect contribution in the source code. The code will be stored on Auslandia GitLab. GitLab, where the code of several open source projects is already stored. Auslandia will have administrative rights and will be able to moderate the contribution. New functionalities will certainly be offered by the issues. Indeed, in the context of this project, we have a certain number of days allotted, so choices had to made, and certain functionalities could not be developed. The user will be able to share their experiences of how they use the platform and how they benefit from it. And finally, development will be made as generic as possible. Indeed, it was developed in an Indian context. Applying this platform to another territory will require some adaptation. The aim of the development is to minimize this adaptation over time. To conclude that part, the work as a team is very important, is essential. The use of agile method is welcome in order to obtain satisfaction from all parties, especially customer. To achieve this communication is essential with regular exchanges to identify needs and limit development that will require adjustment. Regular deployment of new functionalities is important to obtain feedback from the customer and to validate the work. The customer can also take ownership of the platform and is reassured about the direction of the project. The changes are welcome, but sometimes you have to iterate to get the most relevant result possible. But on the other hand, it's important to think about these changes as early as possible to avoid time and energy consuming backtracking. It's important to have a platform that works, but you don't forget about the user and technical documentation to ensure the long-term future of the application. And finally, it's important to maintain a simple process within the organization. I have finished for the second part. Do you have some questions?
Thank you, Vincent. And I invite again the participants to turn your microphones and cameras on in case you have any questions, or send them on the chat as well, and then we will try to answer. I don't see any for the moment, but I have a question myself again, Vincent. You were talking about the customer. I was wondering, when you talk about the customer, this is the person that is asking to develop the Urban Mobility Observatory, because from the other point of view, like the customer could also be the person that want to access this data, but is not the one taking care of it and managing. So I don't know if you could clarify this distinction.
Yes, when I ask about customer, I spoke about the person you apply the platform, the observatory.
If I may, from our point of view as a developer team, the word customer is a generic. So it doesn't matter or if the final people who will just consult the website or an intermediary people which write the specifications in collaboration with the final user maybe and work as a team with us. So I'm not sure if we are answering well your question, but there is many type of customers. Some are really involved in the process. Others are really detached to the process, and we like when the customer is really in part of the process. In fact, it is the way we want to work in the agile prerogatives. It's really an important part of a well-functioning workflow. If the customer is really not part of the process, it may be difficult sometimes to achieve a good result in the end. For the observatories, the final customers, as we can say, are the three cities in India. But for us, the customer were Transitec, DVDH, with who we worked daily when we were developing the software. So the communication was good, the process was good, and we were happy with that. With that, is it a good answer, Nicolas?
Yes, thank you very much. It's just that in my mind, at the end, these urban mobility observatories platforms are accessed by the citizens that might not be experts on urban transport. So the experience of trying to access this data is different for a citizen, like a regular citizen, than for a transport planner, for example. This is why I wanted to make the distinction, but I think your answer was quite complete. Like,
Yeah.
if I can sum it up, the customer should be any person that accesses this data, doesn't matter who it is. It should be available for everyone.
Of course, but to add a few words, it's really difficult when you build a public platform like this to take all the users' opinions. You have to take a small group which make decisions to run the project. Else you won't go any far because there will be too much ideas, too much directions, too much reflection. So we have to focus on some functionalities we choose on a team, on a small team, so we can produce a first version, and maybe in the future it will evolve. We hope it will evolve with other functionalities, with the people asking for new evolution on how the platform could evolve.
Okay, thank you. And we have another question on the chat. In developing an observatory, what would your advice be in instances where there is not enough specialized data?
Concerning the spatial data are not mandatory. Some section of the platform have no spatial data. In this case, the interface is transformer, and the dashboard with the graphic takes up all the available space on the screen. So it's not a problem if you don't have spatial data or few data.
But as a complementary, no spatial data, for my point of view, equals no maps, unfortunately. So you will have charts, dashboards, like we can see on this observatory. But if you have few data, the website may be poor. And like I said before, people, web users want to see rich websites with a lot of informations and complete informations. If you propose a website with too less information or incomplete information, it's from my point of view a problem, because you don't really be sure that the data you see is the right data. And you always ask yourself, but maybe there is some missing data. I don't know. The website is not telling me. So I don't know where I can put myself, if you see what I mean. So it's important to, before entering and wanting an observatory like this, is really to think a lot about the data, to gather a maximum of data before starting to build the application, and be sure you will have the sufficient data to put in the databases.
Thank you very much. And we just got another question that might be the last one, so we can then continue to the next section. And it's related to what we were discussing before at the end of the first section about the skills that a person needs to manage this tool of an urban mobility observatory. And the question is, for someone looking to acquire and improve their skills on this matter, what recommendations do you have? You already talked about like a basic knowledge of coding or like managing the platform, but what else would you add to this list of skills that might be important to manage it?
I would say to have the appetence. I don't know if we say that in English, but appetence to try and to not be afraid of trying to take the code and install it on a local host. A local host is a personal computer. It's easy to build the platform on a private computer. So not to be afraid to take the code and try it out. The documentation is provided in the source code, so you have to follow the instructions and then try it. If we go a bit further, of course, if you know how to use well a computer, I mean very well, and you've got some notions of programming, it's of course better. So if you plan in the future to regularly do some kind of stuff like deploying some websites, yes, you have to follow training. You have to follow some webinars about how to do that kind of stuff. But we can go into details after the webinar if some people would like to have some more details about that.
Thank you very much, Sylvain, for your answer. And I would invite you now to pass to the third and last section of your presentation. We're a bit behind schedule, but I think we can manage to finish in 25 minutes, if that's okay for you.
It's okay. Let's get on with the third part on open source, OpenData, and OpenStreetMap. To introduce this part, we can ask ourselves the following question. If you build an open source application, why not using OpenData? Let's start by defining the open source term. Open source refers to software whose source code is publicly available, meaning that users are free to study, modify, and distribute it. We can cite few characteristics about the open source. Firstly, access to source code. The software source code is available. Free distribution. Open source software is distributed and there are licenses that allow free distribution. Freedom of modification. A user of open source software have the freedom to modify the source code. They can make changes, add new features, fix bugs, adapt the software to their specific requirements. You have a low cost. You don't have to pay for a license. You have transparency. Open source promotes transparency by allowing users to examine the source code. You can do a check on how the software works, identify errors, improve security. And you have a collaborative community. Open source encourages community collaboration and participation. Developer and user can contribute to software development by reporting bugs, suggesting improvements, sharing knowledge, and collaborating to improve the software. Alongside of the concept of open source, we hear more and more about the open data movement. It refers to data that is made available to the public without undue restriction. The data are freely and accessible to all. We can cite some characteristics of the open data movement. Firstly, accessibility. Open data must be easily accessible to all without restriction on access or downloading. Free of charge, open data is made available so that anyone can access it without having to pay fees on or user rights. The third characteristic, reusability. Open data encourages the reuse of data by third parties. This means that users can export them, analyze them, combine them with other data sources, and share them to create new application, visualization, or services. You have an open license. You have interoperability. Is often open data is often published in standardized interoperable formats, making it easy to use and integrate with other data sources. And finally, you have other characteristics like quality and reliability. You have metadata describing the data. Its origin, method of collection are often provided to ensure that it can be understood and used appropriately. And you have transparency by giving the public access to information held by public and private companies. What types of data can you find on the open data portals? On these portals, we will find a wide variety of data, geographic and non-geographic data. The data are generally classified by theme, like demographic, environment, urban planning, economy, transport, finance. Data from different sources, government, public, private. You will find data at different territorial scales, like the country, the region, the city, a group of cities, companies. The data vary depending on the portal. Some portals are very generic and aim for centralization. Others are specialized because of their activities. For example, a company that manages a city transport network. And finally, you have metadata to qualify data and facilitate searches. Data format, year, producer, sim. Concerning the open data in India, I'm not familiar with the Indian context, but I have tried to find open data portals with data on the country. Here are a few links, some specific to India and others centralizing data on countries all over the world. The first link is to the portal provided by the Open Government Data Platform India. This is a platform this is an Indian government platform where we will find a huge number of resources, over 600,000, and we can search by sector and keyword. If you click on data, we will get some metadata, and we can download the data if required. The second side is the National Remote Sensing Center, which provides geospatial data and satellite images for various regions in India. The first site is Humanitarian Data Exchange, managed by the United Nations, and give datasets related to humanitarian crises, emergencies. On this platform, you can do filter your search by type of data. I can check geodata, and I can filter by country, for example, India. You can see the format associated to the data. For example, this dataset can be downloaded as a GeoPackage format. And the last link is OpenStreetMap, a collaborative database that I will introduce later. Here you have a few sites, but this list is obviously not exhaustive. Here there are hundreds of OpenData portals. For what follows, I have decided to focus on a new Indian city. I chosen New Delhi. I have been researching OpenData on this city. I have to admit it wasn't easy. Unlike in France, the OpenData movement seems less developed. After some research, there are a number of sites where you can find data for consultation, viewing, but you can't always download the data. It's semi-open data. I have added links to the platform mentioned above, and I have also added platforms for local players. I finally downloaded some data on bus, metro, administrative zone from the Open City Urban Data portal. You can find 20 datasets on the daily city. If I click on metro, I can download the data, metro station, metro lines, overground metro lines, underground and overground metro lines. And I downloaded the administrative zone from the GADM site, which provides the different territorial levels in countries all over the world. In different formats, GeoPackage, Shapefile, JSON, CamZen, you have a preview of the data. Once the data has been downloaded, you want to visualize it, analyze it, and produce a map. To do this, you are going to use QGIS. Sylvain already mentioned it in the first part. As a reminder, it's an open source GIS software that will allow you to view data, create data, edit, analyze, publish via maps. We are going to import the previously downloaded data, change its style, and perform a spatial analysis. QGIS manages a wide range of formats. The downloaded data on the metro and the bus are in KML format. To add it, I have just to do a drag and drop. I have already downloaded the data. Each piece of data is defined as a layer in QGIS that appears in the Layers panel. I have already added a base map and I have a zoom on my data. I can see the metro station and the metro lines. Quickly, I can change the symbology. I can change, for example, the colors. I want red points for the metro stations. I can increase the width of the lines. With QGIS, I can also perform spatial analysis. For example, I would like to know how many subway stations there are per line. To do this, I will use a series of algorithms provided by the software. My strategy will be count the stations that intersect the metro lines represented by lines. Unfortunately, the points don't intersect, so I'm going to create a zone around my lines so that they touch. For it, I use the buffer algorithm on my metro lines. I choose the distance in degrees. And after this, I use the algorithm gen attribute by location. I get in output a new layer. I open the attribute table to get the result. And I can see the number of station metro per metro line. For example, the blue line is the line with the most station, approximately 66. OpenStreetMap is a collaborative open data map of the world where volunteer contributors add and update geographical data. Some characteristic, it's a collaborative map created by volunteers. Unlike traditional maps, which are often proprietary, everyone can participate to the creation, to the update of the geographical data. The data in OpenStreetMap are open. Contributors add and edit data through online mapping tools such as ID Editor or GOSM. The community plays an essential role. OpenStreetMap is supported by a worldwide community of passionate contributors. These contributors collaborate, discuss, share knowledge to improve the quality and scope of map data. They also organize events, workshops, cartoon parties to promote participatory mapping. The data are used in many projects, in application, online maps, navigation system, to mobile applications, research studies, humanitarian projects, urban analysis, and more. And the data quality varies from region to region and depends on the involvement of local contributors. In some very active regions, data may be very detailed and accurate, while in others it may be less complete. How to search OpenStreetMap data? You have different solutions depending on your technical skills. Firstly, OpenStreetMap offers an online export feature that lets you select a specific geographic area and download the corresponding data. For example, if I go in the OpenStreetMap website and in the daily region, I can export the data in the following area. I can download the data in the point OSM format. You can also download the data from OpenStreetMap from a website, which do regular extraction like GeoFabric, Planet, OpenStreetMap. You can extract data from the Overpass API, which enable extraction from the Overpass language. For example, I want to extract the boundary from the daily. And I can export the different data using the export buttons. You have various formats available. And finally, you can use language development like Python. You can use tools like Osmum, and you can use directly in QGIS via extensions. The most famous is Quick OSM. How to contribute to OpenStreetMap and why contribute? You have many benefits, both for you personally and for the community. Here you have a few reasons to contribute, to share your knowledge. You share your knowledge of the places you know. You can add details about road, buildings, points of interest, public transport. This helps create a more complete and accurate map that benefits to all users. You can improve maps for everyone. Your contribution helps users to navigate, to plan routes, search for places, and make informed decisions. You can engage the local community. You can connect with other contributors in your area and form an active community. You can take part in meetings, capture parties, collaborative projects to improve local data and share knowledge. And finally, you can support humanitarian initiatives. OSM data is used in humanitarian projects to support disaster relief, development organization, and participatory mapping initiative. You can help these humanitarian efforts. But how to contribute to OpenStreetMap? The first step is to create an icon on the OpenStreetMap website. This will enable you to save your changes and participate in the community. Secondly, you have to use the OSM editor. For example, you can use the button Edit on the OpenStreetMap, and you can add point, line, area directly on the website. I suggest you to contribute locally. Start by adding information about the places you know, such as your neighborhood, town, region. You can add road, building, street name, point of interest, pedestrian zone, and more. And you can check and validate data when contributing to OSM. Make sure you follow good mapping practices. Use global sources and check your changes before saving them. And finally, contribute to specific projects such as public transport making, infrastructure details, digitizing buildings. This was the last slide for the third part. Do you have some question about this part?
Thank you, Vincent, for the presentation. I again invite participants to send your questions if you have any. In the meanwhile, I had a couple of questions, but that you answered in the very last slide, because I was going to ask about the quality control that this open data information has, because I imagine, and maybe this is just a very evident answer, but I imagine if there is a lot of people that contribute, there might be also some data that is not very accurate. So I just wanted to know if there is a process to check the quality of this data. And then the second question was related to the availability of data. You did this project in India, and I would guess that in India there is more or less good availability of data, but I don't know what was your experience in the 3 cities that you worked on, and how to manage this, like what's the alternative to open data, for example, in a medium-sized city in which most probably we won't find any data.
I may start about the quality of the data. the users involved in the community are the validator of the data. There is no entity which validate the data. All the users validate the data. And this is a good question because in the OpenStreetMap world, there is also vandalism. Some people which are putting some wrong data, false data, in order to gain something in return. It's maybe political or maybe commercial vandalism, but it's a reality in the open source in the OpenStreetMap community. Of course, there is many contributors, and the overall quality of the data are checked every day by the all user, and the vandalism we can sometimes see is quickly corrected, adjusted by the community. And Nicolas, what was the other part of the question? Sorry.
The second question was about the availability of data.
Okay, Vincent, you want, or I answer that question?
Concerning the second question on the availability, I don't know enough about the Indian context. There are probably certain players who make your data available. For example, in France, public players have access to data from the IGN that provided data for the army, for the public actors. I think there is a similar company in India. Concerning the availability of data for the three Indian cities, the data have been provided by DVDH. For example, we have used OpenStreetMap to retrieve the ferry data on the Kochi city. You have data, but it's not exhaustive.
Yes, hello, if I may just step in. Good morning, everyone. I'm Laura. It's Laura speaking. I was doing the presentation last Tuesday from DVDH. So we've been working with Vincent and Sylvain to develop the website of the Indian Mobility Observatories. And just to complete the answer for this question, so DVDH, we have collected some of the data, some of the spatial or geographical data directly from the public entities or from the stakeholders, the Indian stakeholders, the local entities that were involved in the mobility project and interested by the development of this tool. So that's why we had the opportunity or the possibility to have this first data. But that's also something, well, I think most of the data we would have been able to find it online with open source data, like the line of the metro or the bus network, that kind of thing that can be found on OpenStreetMap. But for instance, we also add or collect data from household surveys or mobility surveys, and that's data that might not be open source data right now, at least for the three cities in India. But with the development of the tool, the observatory tool, it could be data that will be more and more accessible to any user. Thank you.
Indeed, and I think this is like a great contribution of all this data collection that happens around the development of sustainable urban mobility plan to then make all the raw data available for for everyone who wants to access this information. I think that's another very good objective of the Urban Mobility Observatories. I don't know if there are more questions, but we ran out of time. So if you have any other questions, you can contact us directly, and then we will try to answer by mail. We will be sending a follow-up email with a summary of the 2 sessions, with the recording of this session and a report that Laura was presenting on the first session as well, when it's published on the Mobilize Your City website. So keep tuned for further webinars that we prepare by subscribing to our newsletter in the language you prefer, English, French, or Spanish. I would like to thank very much to Julien, to Vincent, and to Sylvain for being with us today. Thank you very much for your contributions or for your presentations. And I wish you a very nice rest of the day to you all.
Thank you all.
Thank you.
Thank you, Nicolas. Thank you all. Bye-bye.
Bye-bye.
Bye.
Goodbye.